I started recording. So let's begin. So Sakshi, can you tell me what we did in our last session? Do you remember anything?
Actually, ma'am, this is the first class.
Okay. So just go through the recordings which are available at LMS, right? So if I'll share what we have done, this is our syllabus, right? So in very first few hours, we discussed about linear programming problem. So how to formulate it, we are done with it. What are the assumptions? What is the graphical method, right? And big M method. These all things I already discussed in my last class as well as the duality, right? Today we are going to discuss about the transportation problem and the assignment problem if the time will allow. So basically transportation problem is nothing but application of my linear programming. In the linear programming problem, I am saying it is going to work with optimization of solutions. So the same concept is applicable on transportation problem also. But what is the major difference? Whenever I was working for LPP, there was no restriction. I can do minimization of cost or I can do maximization of profit. But here in the transportation problem, as entire thing is based on cost, so all the methodology which is developed is based on minimization of the costing. Okay, minimization of cost. So this is specification about the transportation problem. So in this particular session, we are going to learn what is transportation problem, how we can write a generalized form of transportation problem, how we can receive the solution for it. So in LPP, whenever we find the solution, first we start with the initial values, right? And by using the iterative methods, we get optimization of that. So we are going to learn here how to calculate initial basic feasible solution. And while calculating initial basic feasible solution, we are going to find different methods are available. So how to solve with it. Then we have optimal solution. So among all the solution, what is that particular answer or what is that particular value, which is nothing but minimum for making in concern of the cost. Then we are going to talk about what is the solution for modifications in terms of if this is the best solution, how to rectify, how to check that, right? So we have two methods for that. We are going to focus majorly on modified method, right? So all these things we have to learn here in terms of real world problem. So let me first introduce how we write transportation problem. So in the part of the formulation, you need to understand there are going to be two important words. One is known as source and second is known as destination. So whenever any of the commodity is transferred from one place to another with some cost, right? I need to take care of that costing should be as minimum as possible. By taking care of whatever be the supply units are available at the source must be satisfied and whatever the demand at the destination must be satisfied. So by keeping the constraint of supply and demand values, I need to create a graph in such a manner so that the costing involved in it must be as minimum as possible. So when I'm saying units of demand or units of supply, so it means I'm talking about whatever the product is generated, whatever the product is produced, they are going to be transport from your sources to different destination with some cost, right? So I'm going to have the weightage with respect to cost. So if I'm talking about sources, what it could be factories, it could be warehouse, it could be raw material warehouse, it could be finished good warehouse, right? And if I'm talking about destination, it is going to market, it is going to finish good warehouses, raw material warehouses, and factories, right? So this way we understood the concept of source and destination. So now this source and destination, whenever discussed, you can understand. Let's say I'm having 1 to m sources, right? So these are those places where the production is going on. And now this produced values, I need to uh, forward it to the destinations. So I'm having the destination from D1 to DN. So you can see for each and every path, I'm going to have some cost involved in it. And how I'm going to represent that cost, you can understand it with CIJs, right? So costing is known to me, like from destination one, sorry, from source one to destination N, if I'm going. So let's say the cost involved per unit is 5 rupees, right? Similarly, from the source 2 to the demand at destination D1 is suppose the of 7. These are the values and per unit costing is given. So I'll just create the sum product of it and I will receive nothing but the total cost involved. So multiple solutions are possible and all may satisfy the things, but it is not going to satisfy your objective. If you remember, in our LPP we have three major parts. Number one, what is my objective function? Second is my constraints, my limitations. And while doing about the constraint, we say the decision variables are going to be non-negative. What is the meaning of non-negative? It is possible that number of units from mth supply to the first destination is, let's say, 0. That means I'm not going to transport any value from here to here. Or it is possible that I will do. So if I'm going to do, it is going to be positive, but it is 0. Therefore, we call this is my non-negative restriction. So in this, whenever you are working for the solution means it satisfy all your equations, right? But whenever I'm talking about optimal solution, what is the difference? Optimal solution is the solution which satisfy all the constraints as well as your objective function. So if you remember, in general LPP, we were saying my objective could be max, could be mean. But here in the transportation, it is related to the transportation cost. So definitely my objective function is to minimize your cost, right? So what we have to find out, I need to find out how many number of units to be transported, and second, how much is the cost involved in it. Therefore, what is my total cost? Any question? Sakshi, is that fine for you?
Yes, ma'am.
Okay, great. So there are this theory you will receive and you are going to read it in form of PPT. But yes, I'll just brush up quickly the terminologies which are required for this model. Number one, feasible solution. So what is feasible solution? Non-negative values of Xij. What is Xij? How many number of units are going to be transported which are satisfying supply as well as the demand. Basic feasible solution, it is nothing but the number of positive allocations what we made at initial level. Optimal solution, the solution which is best among all, right? Best among all means which is minimum value among all transportation cost values. Now, so far, whatever we have learned, all these three terminologies we have used in LPP. Now, this is important. This is important. In place of that, this is new. Balanced transportation problem. A problem is said to be balanced one if the number of the supply units is equivalent to the number of demand units, right? So if I'm saying there are five suppliers, right, and there are three destinations where the values are needed. So number of supply, total number of units to be supplied should be equivalent to total number of demand. If this thing happen, then I say my system is balanced in the nature. But if suppose your value of supply is more and demand is less, or reverse, the supply is less and demand is more, then we call this is unbalanced transportation problem. So always whenever we begin our journey in the transportation problem, I need to check whether it is a balanced or unbalanced. The reason behind is if the data set is unbalanced in the nature, I know like how I can convert, right? So I'm going to teach that portion soon. If suppose any transportation problem is unbalanced, how we are going to make it balanced one. Then we create a matrix. We are going to create a square, a cell where I'm going to represent vertical and horizontal in a vertical and horizontal way is nothing but how much is the cost involved in the moment. And then we grade the degenerated basic feasible solution. This is nothing but the number of allocation in your basic feasible solution, which is always going to be m plus n minus 1. Now, what is this m plus n minus 1? M are nothing but my m suppliers. And what is my n? The n destinations. So this should be m plus n minus 1. So if simply you connected it with your matrix, you will find number of rows, number of rows plus number of columns minus 1. So that should be the ideal condition to make allocations. Now we will see how to get, yeah. Now if suppose you are checking the demand and supply, if your demand is more, then what you need to do, you need to create one more source. If the supply is more, then what you need to do, you need to create a new demand place, right? So this way we create the dummy row and the dummy column, where the costing involved in it, these dummy rows and dummy columns are going to be zero. Now we will see how to get the solution of it. So solution for transportation problem is divided in a two portion. First, we calculate basic solution and then we get the optimized values. So to get the initial basic feasible solution, I need to go by three different methods. Method number one is known as northwest corner method. Second is least cost method. And third is Vogel's approximation method. These three methods are going to give me initial, what is my initial basic feasible solution. So let me introduce you what is this basic and non-basic. If I just give one equation to you that x plus y is equals to 7, right? And if I ask you what is the value of x and y, definitely you will answer as number of unknowns are 2 and equation is 1. So it is not going to give me a unique solution. It is going to have what? Infinitely many solutions. If you remember in our matrices, we learned this system is consistent and system is inconsistent. So what is the meaning of system is consistent? That the solution is going to happen, and inconsistent means the solution will not exist. But if solution exists, there is again two properties. Number one, either it is going to have one and one solution or it is going to have infinitely many solution. For example, if my value of x is 1, then corresponding to it, you receive y value is 6. If my value of x is zero point 0.5, correspondingly, you receive the value of y as 6.5. Am I right? And this way, multiple solutions are possible. So all these values are going to satisfy the given set, but this is not going to satisfy the objective function. If it satisfies the objective function, then I say this is my feasible solution. So how we are going to have my basic solutions? Those variables which are treated as non-zeros are said to be basic variables, and those variables which are treated as zero to get the value of remaining variables is said to be non-basic variable. So if I say here my value of x is equals to 0, so this x equals to 0 becomes what? My non-basic. Okay, and because of that what I received, that is y is equals to 7, is my basic, right? So basic, feasible, done. Now term is initial. Whenever you are starting your system, initial values, when you made some assumption and you are moving ahead, that term is known as initial basic feasible solution. As we learned in our graphical method, we said that because of x and y belonging to first quadrant, they both of them are greater or equals to 0, my system is starting from origin, right? It is going to start with 0 comma 0, assuming that there is no production. But slowly gradually, because of the number of constraints, what we observe, we receive a feasible region, and whatsoever is the farmost point, that point is going to give me the best solution, or you can say that is going to give me the optimal solution. But it may possible you will receive that solution at two different points, so it becomes optimal solution. Now let us focus about initial basic feasible solution in by using these three methods. So there are some steps what we need to follow. I'll take one question and one by one we'll solve it. Sakshi, are you still there? Okay, so we'll continue. So this is my minimization problem to get the minimization the cost, right, by using NWCM. What is this NWCM? Northwest corner method, right? So look at this question. We just need to find out the allocations and the total cost involved in it. And that cost, if I say it has to be minimum, then I need to compare all these methodologies. So if you see here what is number of plants are given P1, P2 and P3, and they can supply how many units? 20 units, 28 units, 17 units, right? So P1 is able, the plant P1 is able to supply 20 units, plant 2 28 units, and plant 3 17 units. So if I'll simply add all these values, it is going to give me summation of my supply, and I got the answer 65 for this. In the same way, there are three warehouses, W1, W2 and W3, and I can check their corresponding demands as of 21, 25 and 19. So if I'll just add all the demand figures, it is going to be 21 plus 25 plus 29. So it is again giving us the value 5. So what you observe, the very first thing I checked, that summation of supply, this is a sign of summation, is equals to summation of demand. If both of them equivalent, what we say, the given problem is a balanced problem. So first thing is to check whether the given scenario is balanced or unbalanced. Balanced. Then second step. In the second step, what you have to do, you need to begin with your northwest corner. As the name itself is saying, this entire methodology is based on to begin with the northwest corner. Now, these figures, which are written here as 7, 6, 5, 8, and all, what these values are indicating, they are indicating nothing but the per unit costing to transport, right? So, this 7 is nothing but what this 7 is indicating. The 7 is indicating if I took a decision to transport single unit from plant 1 to the warehouse 1, I need to pay 7 rupees. So for this purpose, what you do, always pick northwest corner point. Pick northwest corner point. Right? So what is that northwest corner point? This is north, this is south, this is east, this is west. So I understood that this is nothing but my very first northwest corner point. So you begin from this northwest corner point. For this position, check the demand and check the supply. That means plant 1 can supply 20 units. Warehouse 1 is having 21 units. So how much of the maximum, how much is that minimum number of figures which I can transport is going to give me third. Pick the minimum of your rows and columns, right? So because of that, you understood here, this is that point and demand is of 21 and 20. And as it is saying minimum, so it is going to be how much? 20. So make an allocation here of 20. What this 20 is going to indicate? This 20 indicates that I can transport number of units from P1 to W1 of at per unit costing of 7. And how many units I can transport? So it is coming 20. So the moment you have made the allocation of 20, this P1, which is having supply units of 21, is over, right? It is no more the part of your question. So just eliminate it. Done. So once you have done it, you got this 21 becomes 0 and this 21 becomes 1. That means still there is a demand of 1 unit from the warehouse 1. Now, initially it was 3 cross 3 inner matrix. Now, if one row is eliminated by using the row operation, I reached to the second one. So, which says again the northwest corner point is this 5. Again, check the demand and supply. Demand is of 1 and the supply is of 28. So, how many number of units to be allocated? Can someone answer? So, minimum of 28 and 1 is 1 only. So, I'll make the allocation of 1. And so this becomes 0 and this becomes 27, right? Now, if I'm going by this, it indicates that there is no significance of the warehouse 1. So initially, which was given to me is of 3 cross 3 matrix. Now it reduced it to a 2 cross 2 matrix. Again, go for the northwest corner point. This is my northwest corner point. Check the demand and supply 25 and 27. Minimum is coming 25. So I'm making allocation of 25. So this 25 becomes 0 and this 27 becomes 2, right? Moment you are making it 0, your W2 is going to be not going to be the part of your solution. Now, again, northwest corner point is nothing but this 3. For this 3, check the demand and supply. So demand is still of, sorry, demand is still of 2 and the supply is of how much? Of the demand is of 19 and supplies of 2. So whatever the small, I can make allocation. So this becomes 2. So this becomes 0 and this is 7. And moment it becomes 0, there is no significance of P2. So now for P3, that is the third one, 17, from the 17 you are getting 8, right? And here nothing was there, but you got the allocation of 2. So once you are making these allocations, so cancel out 270 left. And now if you observe the very last one, supplies of 2 already made, so 0 and 17. So I left with 17. Fine. So here if you count, you have made the allocation, then you check the transportation cost. Transportation cost. And how to check that? 7 is the number of units multiplied with 20. Then 1 unit, sorry, with the cost of 5 rupees, 1 unit is transported. Plus 7 times 25 plus 3 plus 3 times 2, right? And similarly, keep going on. And that will give me my transportation cost, right? So let me take once again the entire question. Okay, so please give attention to the northwest corner point, 20 and 21. So 20 is smaller, so make this 0 and make this 1 and make an allocation of 20. So it means there is no significance of the first row. Again, I've reached to the second row. I'll make allocation of 1 unit. So this becomes 0 and this becomes 27. Done. Whatever becomes 0, just cancel. Next is this 7, 27 and 25. 25. So this becomes 0 and this 27 left with 2. Done. Whatever becomes 0, eliminate it. Now I have 3 and 8, but I know northwest we are following. So at 3, the options are 2 and 19. So make 2. And this 19, from the 19, 2 already made. So 17. So this 18th question is going to be with 17. So from P1 to W1, number of allocations is going to be 20 and per unit cost is 7. So total cost right? Total. So that is 140. Similarly, from P2, from P2 to W1. Number of allocations, I made allocation of single unit. Per unit cost is 5. So that's why 5 only. Third is P2 to W2, right? Number of allocations I made is 25. Be careful, I'm writing allocations in circle and the given value is my cost, right? So I got 175. Then we have P2 W3. Number of allocations 2. Per unit cost 3. Total cost 6. P3 W3. Number of allocations 17. Number of cost per unit cost is 8. So total is 6, 5, 13, 136. Right? So if I'll just simply add all of these, so here the total cost involved in it is coming 362. Just I'll just confirm this figure. Done. So this is my transportation cost. But which method we adopted? We adopted northwest corner method. What is the drawback of this method? I'm not at all taking care of this part. If you want to minimize the cost, I should opt those values where the costing is least. But I'm just going through the position. That means I'm just going it by the direction wise, and whatever is the corner, that corner, I'm going to make the allocation. Right now, if I'll check my number of allocations. So my number of allocations, what I'm getting here, if I'll count, is coming 5. This number of allocation must come equivalent to the number of rows plus number of columns minus 1. So here in our question, the number of rows are 3 and number of columns is also 3. So 6 minus 1, that is also coming 5. So whenever the number of allocations and number of rows are equivalent, we say the rim condition is satisfied. Rim condition satisfied. And whenever the rim condition is satisfied, I may move towards the optimality. But if suppose the rim condition is not justified, we cannot go for optimality. We need to create a degenerated solution, right? So how we create the degenerated solution? Randomly at the minimum cost, we make a small allocation and then we proceed. Fine. So is northwest corner method is clear to everyone? Isaac, what are you doing here? Isaac?
Mm, Yeah, I come across the link on my group and I saw you are the one taking the course. I said, let me just double in and get some
Okay, okay, okay.
experience.
No, not a problem, not a problem. I would just want
Thank
to
you.
check,
Thank you.
like, no problem. I have
Mm,
shared
mm.
that link for MBA class, okay? Just to confirm once.
Yes, I've got it.
Okay, fine,
Got
dear,
it.
fine. So are you finding this interesting?
Very, very interesting.
Okay, great. So
Mm.
now we will move ahead and we'll go for the next method, which is nothing but least cost method. As I said, there's a drawback of this method that we are not giving priority to the minimum costings. So we made changes in it and we are going to solve the same question with least cost method. Sorry. Yes. So for this least cost method, what we need to do, we are going to give the priority to that particular position wherever the cost is minimum. So whatever the payoff is given to me right now, it is giving me the cost as well as it is giving me the demand supply values. But if I'll just observe this inner portion, that is of 3 cross 3 matrix, I will get all the values which are with related to the cost. So among all the cost, go for the minimum cost. So that is how much? 3 here. For the 3, check the demand and supply. Whatsoever is coming least, market. So I'm getting 19 here. So this 19 becomes 0. That means warehouse 3 were demanding for 19 units and you have given it. From where you have given it? Through the P2 plant. And P2 plant, how many units he can supply? He can supply 28 units. So if 19 is already allotted somewhere, so he left with how much? He left with 9. Done. So whatever becomes 0, just eliminate that row or that column. Now whatever figure left with me, it is nothing but three rows and 2 column. Minimum value is 4. So I'll make allocation at this 4. 21 and 17 are the demand supply values. Whatsoever is smaller, I'll make the allocation. So this 17 becomes 0. What does 17 become 0 indicate? The plant P3 having supply unit of 17 and he can make the allocation of 17. But the demand for this particular was of 21 and I have just given 17 units. So how many units left as of demand? 4 units. So I'll keep this 4 here. Whatever is becoming 0, cancel this. So this becomes 0. Now figures left with me 7657. These are nothing but per unit costing. Again go for the minimum value. So this is my minimum 5. For this 5, check demand supply 4 and 9. Make allocation of 4. So this becomes 0 and this 9 becomes 5. Right? And then I can cancel out this entire W1. Fine. Now you can observe here, you're left with two costs, 6 and 7. Minimum is 6. For this 6, check demand supply, 20 I can apply. Supply becomes 0, demand left with 5. And now there is one and only one cost left, as that is 7 with demand and supply units of 5 and 5. So you can make the allocation of 5. If you observe in each and every methodology, at the end, it is going to be equivalent. Reason behind, we are working for balanced transportation problem. We have checked what is the total demand and what is total supply. If suppose it is unbalanced, I need to make it balanced and then only I will left with the same number of units column wise and the row wise. So we are done here. So how many units we made, how we made the allocation? P1 to W2. Number of allocations. And next is total cost. You can write per unit. So we receive here figures 20. This is 6. And therefore the total cost 120. We have P2W1. Allocations 4, per unit cost 5, total 20. P2W2. Allocation is of 5, cost 7, 35. P2W3. Allocation 19, 3. And last P3W1. Allocation is of 17, per unit cost 4, 68, right? And therefore the total cost is going to be. So I'm getting the value 300. It is coming 300, right? So 300 is the total cost. So if we cross check or we can compare it with our previous result by a northwest corner method, that time the total cost was coming 462. Now if you see here, the cost is reduced and it becomes 300. And here also, if I check the m plus n rule, that is number of rows 3, number of columns 3, 6 minus 1, 5. So number of allocation, I am getting 5. Number of allocations. So that means I am eligible to find the optimal solution. So if we just compare these two methodologies, in the first methodology, we are giving preference to the position, but in the second one, we made a change and we are giving preference to the minimum cost. And because of that, we observe number of allocations we can made and I can save almost how much? Here the figure was 462, almost 162 rupees. Am I right? Now there is the third method and we call that is Vogel's approximation method. So this Vogel's approximation method is basically based on, yes, this is my Vogel approximation method. This methodology is based on penalty, right? How much is that regret value? Okay, if I could have taken a wrong decision, then how much are the values of my regret and how I can rectify? So for finding IBFS by using Vogel's approximation method, what I need to do, I need to first find the regret values and then I'll work around it. So this method is assumed to be the best. It may possible you will receive the optimal solution here only. That this is my optimal solution. This is that best solution what I'm looking forward for. So let us do same problem I'm going to take, but I'm going to do it with the third methodology, that is my Vogel's approximation method. Done. And make sure whatever the matrix is given to me, it should be for the cost, right? Then only I'll be able to get then only I'll be able to get IBFS. So how to perform this? Here I'll write 7, 6 and 9, right? Minimum is how much? Minimum is 6 and maximum is how much? 9. So for each and every row and column, we are going to find the penalties. For each and every, look at this. For each row of the table, find the lowest and the next lowest and find the difference. And this difference we have to find out for each row and for each column. So the lowest and the next lowest. So let's find here. The minimum value is 6. Next figure is 7. So difference between these two is 1. So penalties I'm writing in this square. Why? Just to get a clarity, just to have a differentiation with other values. And the second one, minimum is 3, next one is 5. So the penalty is of 2. So what this penalty is indicating, if I could have made a decision to have this 7, but actually it should be how much? 6. So I am paying extra of 1. So that extra of 1 is my penalty. Here we will have 5 and 4 penalties of 1. Now in the same way I can make a wrong decision while going through the warehouse wise. So value here I receiving 1. Here it is 1 and last 3 and 8. So that is 5. So what these square bracket values represent? It is nothing but representing the penalty values. Now obviously I have to reduce my penalty, right? So where I'm getting the maximum penalty, there I need to work. So I'm getting the maximum penalty for third warehouse, that is of 5. So this maximum penalty value indicating here you need to take action. What action I'll make? I'll make, again I have choice 9, 3 and 8 are the are different cost values. I'll pick the minimum one. So I picked this 3. I check the demand supply, whatever is the minimum, I'm going to make that as an allocation. So this become 19 and this is 0. And here how much left? This left 9. right? So just cancel warehouse 3 because you satisfied the demand of it. Again, you find the second round of penalties. So row wise first. So 7 and 6 only two figures, 5 and 7 two figures, 4 and 5 one. So it has been observed whenever you delete any of the column, there is no change in penalties row wise. But if you delete any of the row, then there is a change going to happen for the column penalties. So here values are going to be 4 and 5. So this is 1, 5 and 6. So this is 1. Now where I am getting the maximum penalty? Maximum penalty is of 2. So I need to enter a for the plant 2. For the plan to check the check the minimum cost that is coming 5. For this 5, check demand and supply 9 and 21. So I can definitely make assignment of 9 units. So this 9 becomes 0 and this 21 left with 12. So we satisfied 9 units as of demand value, but still I have a requirement is of total requirement was of 21. So still there is a requirement of 12 units. Then cancel P2. Now the new set of penalties, third round. So that is 1 here. This is 1. This is already gone, so not required. 1. Here 4 and 7. So you left with 3 and 5 and 6 left with 1. So maximum penalty, I'm getting this 3. For this 3, costing values are 4 and 7. So minimum is 4. Check demand supply 12, 17. Make the allocation of 12. So this becomes 0 and this 5. Done. Now, therefore, there is no role of this W1. Now, if I ask you for the penalties, now there is no penalty involved directly. That number itself is my penalty, right? So I'll write 6. Here I'll write 5. And this one is 1. This is my 1. So go for again maximum value 6. 6 is having only one and only one figure there, one choice 6. Check demand supply, make allocation 0 and 5. Cancel your first plant rule. Last figure. See, the per unit cost 5, demand 5, supply 5. This thing happened because my system was balanced. So make allocation. So if I compare it, I'm receiving here P1 to W2, right? Number of units 20, per unit cost 6. Then we have P2 W1, number of units transported 9, per unit costing cost, number of allocation. Then we have P2 W3, that is number of allocations 19, per unit cost 3. P3 W1, number of allocations 12, per unit cost 4. P3 W2, number of allocations 5, per unit cost 5. Done. And again, if you will check, m plus n minus 1 is equals to 5 is equals to number of allocations. And how much is going to be the total cost? We simply create the sum product. Right. So total cost is coming 120 plus 45 plus 57 plus 48 plus 25. So altogether is coming 295. So if you compare, right, this one is the least. Why this one is the least? Because in my northwest corner method, it was 462. By using least cost method, it becomes 300. And when I worked with respect to the penalties, I'm able to eliminate the error wherever it's possible. My minimum cost involved to justify the demand and supply is of 295. So this is the best. This is the best solution, right? Now, once you, which one, ma'am, is I need to apply? If it is nothing is mentioned in the question, then you can go by any one of them. But if suppose the question comes to compare or to get the best optimal solution, then you need to go by the then you need to go by the Vogel's approximation method, right? So today we learned about initial basic feasible solution, and we understood that Vogel's approximation is the better, and sometimes it gives same answer as your optimal answer. Now we have the next step where we check this optimality, whether whatever the answer I receive is that optimal or no. And we have two methods. Number one is the stepping stone method, and second is UV method, or the another name of UV method is Modi distribution method, MODI, modified distribution method, right? So I think we left with hardly few minutes. So in the next class, if you find it difficult, then I'll take it. By that time, I'll keep some recordings for the same topic. Just go through it and try to make out if you can solve. As uh, today we didn't finish the decision, this transportation problem. So queuing theory we will take in next session. But yes, try to solve problems based on uh, optimality, right? I just give you the hint in the optimality test. In the stepping stone, what we do, wherever I then made any allocation for those values, I'll find out the costing, and wherever it is minimum, I'm going to pick. But this is a very confusing and tedious job. So we made it simple by modified method. That's why its name is modified only. What you have to do, what I understood in the optimality test, that whatever the solution I receive, it whether it is best or no. So for that part, what I need to calculate the value of delta Ij. And this delta Ij is my opportunity cost, right? If my this delta Ij opportunity cost is going to be, if suppose any problem is maximization type of, then all delta Ijs must be in combination of negatives and zeros strictly, right? Again, I'll repeat, it is going to be either greater than or equivalence to zero, right? So this delta Ij we are going to calculate by finding it as Ui plus Vj minus of Cij, right? So for each and every component where there is no allocation, you calculate. And wherever you find, whenever you will check with this delta ij's, it could be positive, negative, or zero, right? So if any negative value arises, it means there is a scope of working around it. Okay. If it anywhere you are getting zero, same system is going to have unique solution, but I need to calculate that unique solution. Is that fine? So this is for today, but for sure we will do it in the next class. But by that time, you just go through the recordings and come with your doubts. Okay. If I'll connect here, this transportation I started today and we finished this much, right? This optimal solution of the transportation problem by Modi method, you can see this in the syllabus. You need to refer recording what you are going to receive soon. And same Hungarian method to make the assignment, you will receive the same type of recording and you just follow. And in this way, we reach to the fourth module, game theory. This game theory we are going to we I just planned it to do it today, but as there is no time left, so we'll do it in the next class. And then this decision theory, the entire recording for this decision theory is available. So just go through it. So I'm not going to take the decision theory as explaining each and every concept. If you have any specific doubt in it, I'm happy to explain, right? So I think it's enough for today. We'll continue in the next class with further information and questions. Okay. Thank you, everyone. Thank you, Isaac.
Thank you, ma'am. Very interesting.
Thank you. Thank you, dear. Thank you.
Mhm.